Hello guys, welcome to chapter 2. We are now in chapter 2 of digital electronics. So in this chapter, we're going to learn the Boolean theorems and logic gates. So at the end of the lecture, the students must be able to simplify Boolean equation using Boolean theorems in algebra, explain truth table, and discuss minterms and maxterms to formulate Boolean equations using either minterms or maxterms, and present Boolean equations either in standard or in canonical forms. Then discuss basic logic gates, be able to draw the logic circuit diagrams based on simplified Boolean equations. Okay, so let's get started. So in this chapter, so let's begin with Boolean theorems. Okay, so Boolean theorems is more like an algebraic theorems or algebraic property. Okay, so let's proceed. So let's start. So single variable theorem. So x times 0. So when you say x, so it means that it could be either 0 or 1. Okay, so x again can either be 0 or 1. So example here, if x times 0 is equal to 0, why? So if x is equal to 1, then 1 times 0 is equal to 0. And if x is equal to 0, then 0 times 0 is still equal to 0. So the multiplication is represented by a dot here. Okay, so we have a dot to represent multiply. Okay. So for number 1, so any number multiplied by 0 is 0. How about number 2? So number 2 says that x plus 0 is x. Why is that? So if x is equal to 1, then 1 plus 0 would be equal to 1. And if x is 0, then 0 plus 0 is still equal to 0. So in this case, so the sum would still be equal to your x. So whatever the value of your x, so that would be your sum. Okay? So how about x times 1? Okay. So x times 1 is equal to x. Okay, so how so? So if x is equal to 1, then 1 times 1 would be equal to 1, which is equal to your x. Okay, so your x here is 1 here. So 1 times 1 is 1. And likewise, if x is 0, then 0 times 1 would still be equal to your 0, which is equal to your x. So therefore, x times 1 is equal to x. Okay, so how about x plus 1 is equal to 1? So for x plus 1, so we have if x is equal to 1, then 1 plus 0 is equal to 1, and okay, which is also your x. Okay, and if x is 0, then 0 plus 0 is 0, which is also your x, which is also equal to x. Then therefore x plus 1 is equal to 1 is true. Okay, true. So when we say prime here, x prime, so that means the invert of x. So when we say x, so therefore if x is 0, then x prime is equal to 1. Okay, or vice versa. If x is 1, then x prime is 0. So therefore, if x is 0, then x prime is 1. So that means that for x times x prime, then 0 times 1 is equal to 0. Still be equal to 0. Or vice versa, if x is 1, then x prime is 0. Then 1 times 0 is still equal to 0. Because any number multiplied by 0 is still equal to 0. Next, we have x plus x prime is equal to 1. So if Okay. So if x is 0, then x prime is equal to 1, then 0 plus 1 would still be equal to 1. Okay. Likewise, if okay, so otherwise, if x is 1, then x prime is 0. So therefore, 1 plus 0 would still be equal to 1. Okay, I hope you don't get confused. Okay. Then x times x is x. So if x is 0, then 0 times 0 is 0. If x is 1, then 1 times 1 is 1. Okay. How about x plus x? Okay. So x plus x, if x is 0, then 0 plus 0 is equal to 0. If x is 1, then 1 plus 1 is equal to 1. Okay. So how is that? So let's have it here. Okay. Okay. So simply put, so we have, oh, what's that? If x is 1, then 1 times 1 is 1. Okay, if x is 0, then 0 times 0 is 0. Okay, whereas here, okay, if x is 1, then 1 plus 1 is 1. And if x is 0, 0 plus 0 is 0. Okay. So there you go. That's for your single variable theorems. Okay. So I hope you don't get confused. Okay. Let's proceed to multivariable theorems. Okay. So we have, for multivariable, we now have two variables. We have x and y. Okay. So we now have x and y. So 9 and 10 is the same as you have the algebraic property for 9 and 10. So for 9 and 10, so what do you call this property? Okay, so we're in x plus y is equal to y plus x. So you can interchange the position of x and y. Same with number 10, x times y is the same as y is equal to y times x. So what do you call that algebraic property? Okay, so you remember your algebra. Okay. So we call it as commutative property, okay, for 9 and 10. Whereas for 11, let me see, 11, 12, and 13. Okay, so for 11, 12, and 13, so what do you call that property? So x plus open parenthesis y plus z close parenthesis is equal to open parenthesis x plus y close parenthesis plus z is equal to x plus y plus z. Okay, that's for 11. And for 12, so we have x times open close parenthesis yz close parenthesis is equal to open parenthesis xy close parenthesis z is equal to xyz. Okay, and for 13 we have, okay, so that's it for 11 and 12. Okay, so let me stand corrected. Okay, allow me. So I'm only referring to 11 and 12. So what do you call that? So you can y plus z. Okay, you can include in the parenthesis the y plus z first, and or x plus y first. Okay, or none at all. Same for 12. So we can enclose in the parenthesis the yz first, or the xy first, or the xyz. So what do you call that property? Again, algebraic property, we call it as associative property. Okay, we can do that here. Okay, so how about here for 13 and 14? So we have x open parenthesis y plus z is the same as xy plus xz. So that is for 13. And for 14, w plus x open close parenthesis times open parenthesis y plus z close parenthesis is the same, is equal to wx plus xy plus wz plus xz. So what do we call that property? Okay, for 13 and 14, so we call it as distributive property. Okay, so we call it distributive property, same as algebraic functions. Okay, for x plus xy is equal to x, so why is that? So we have we can use some algebra here. So we can factor out x here such that x, if we're going to factor out x, so it becomes 1 plus y. And based on our single variable theorem, okay, so based on single variable theorem, so let me see. So 1 plus y is the same as number 3. Okay, so based on single variable theorem, okay, sorry, here. Okay, based on single variable theorem number 4, x plus 1 is equal to 1. So therefore, 1 plus y is equal to 1. Okay, so therefore, x times 1 is equal to x. Okay, so whenever you see x plus xy, so you just simply equal that to x. Okay, so just simply give that equivalent of x. How about the x plus x prime y is equal to x plus y? So we have here, okay, why are we always looking for x? So I think you can just simply let them go. Okay, so x plus x prime y. So let's have a table here first. Okay, so let's do some tabulation. Okay, so let's just okay, so let's say we have x and y. Okay, so let's have a, okay, so these are the possible combinations. So if you have x and y, okay, and last we have 1 1. Okay, so if you have two variables, so we have 4 possible combinations. So x, if you have x and y, so we have possible combinations are 0 0 0 1 1 0 and 1 1. Okay, so what is the x prime here? So x prime is the inverse of x. So if x is 0 here, so we have 1. Okay, so x is 0 again, so we have 1 again for x prime. And next we have, if x is 1, then x prime is 0. Then next is, if x prime is 0, then we have 1 here. So that is for x prime. And then how about x prime y? Okay, so we multiply the x prime with y. So we multiply the x prime here with y here. So we have, okay, such that we have 1 times 0 is 0. Then 1 times 1 is 1. 0 times 0 is 0. And 0 times 1 is still 0. So we have the answer for x prime y is 0 1 0 0. Okay, and then we add it with x. Okay, so we add the x prime with x prime y. Okay, so we add this x prime y here with here, such that the answer is 0 plus 0 is 0. Next is 1 plus 0 is 1. Next is 0 plus 1 is still equal to 1. And 0 plus 1 is still equal to 1. Okay, so let's compare it with x plus y. Okay, so we just compare it with x plus y. So with x plus y, so we have 0 plus 0 is 0. 0 plus 1 is 1. Okay. 0 plus 1 is 1. And for the third row, we have 1 plus 0 is 1. Okay. And last, we have 1 plus 1 is still equal to 1. So as you can see here, the x plus x prime y has the same value as x plus y column. So therefore, we can say that x plus x prime y is equal to x plus y. So what every time you see this equation, x plus x prime y, just simply simplify it with x plus y. Okay? How about De Morgan's theorem? De Morgan's theorem, so x plus y, open close parentheses, prime is equal to x prime dot y prime. So what does it mean? So every time you see a prime outside the parentheses, so if you want to put it inside, include it inside the parentheses, so you may prime the variable here. Okay, so take note there's no prime here before, but then when you put the prime inside the parentheses, so you have the variable now is prime, just like in xy, x and y. Okay, so it now becomes x prime, y prime. But you have to change the operator from plus to multiply. Okay? So that's why the operator is changed from plus to dot. Dot means multiply. Okay? Likewise, so for number 18, you have x times y, open close parenthesis prime. Okay, so again, you want to put the prime inside the variable such that it becomes x prime, y prime, but you have to change the dot or the operator from multiply to plus. Okay, so such that for 18, so x times y, open close parenthesis prime is equal to open parenthesis x prime plus y prime, then close parenthesis. So that's how you do it. So you can put the prime inside the parentheses, but you have to change the operator either from plus to dot or dot to plus. Okay, I hope you got it. Okay, let's keep the energy. Okay, let's get started. Before we proceed, so let's have some activity here. Okay, simplify the following Boolean equations. So let's have some examples here. So x plus xy plus xy prime. Okay, so every time you solve for Boolean functions or Boolean algebra, okay, you have to do it step by step so that you won't get confused. Okay, so example here, x plus xy plus xy prime. So how are we going to do this? Okay, so let's factor out the x first. Okay, x plus x times y plus y prime. Okay, so from single variable theorems, so y plus y prime or x plus x prime, okay, is equal to 1. Okay, so equal to 1. So that's equal to 1. Why? Okay, so if y is 0, then y prime is 1. So 0 plus 1 is 1. So therefore, this becomes x plus x times 1. Okay, and x times 1, okay, so from single variable theorem, x times 1 is equal to x, whatever the value of x is. Okay, so x times 1 is simply equal to x, and x plus x is equal to x. Okay, so you got it right. Did you guess it right? Okay, don't guess, please. Start analyzing. Okay, let's have number 2. Okay, AB times C plus A prime plus B prime. So what are we going to do with number 2? So first thing to do is to distribute AB. Okay, so let's see. Okay, so AB times C is ABC plus AB times A prime is A prime B. Okay, so for second term, so AB times A prime is A A prime times B. And for third term, so AB times B prime. Okay. So we have ABB prime. So that's the answer. Okay. Okay. So ABC. So we just copy ABC here. Okay. And then A times A prime. So what do you? So how are you going to simplify A? Simplify A prime. Okay, so from single variable theorem, so x times x prime. Okay, if x is 0, then x prime is 1. So 0 times 1 is 0. So therefore, this term is already equal to 0. Okay, and likewise, ABB prime. Okay, so we have BB prime here. Actually, this is 0 times b, but any number multiplied by 0 is also 0. Okay. So we have bb prime for bb prime. So if b is 0, then b prime is 1. 0 times 1 still equal to 0. Okay. Okay, so I'm just showing you in detail. 0 times b or 0 times x. So any number multiplied by 0 is 0. Okay, so this is supposed to be equal. Okay, and likewise, a times 0 is still equal to 0. Of course, this is simply equal to ABC. Okay, so next we have, how about this one? X prime plus y open close parentheses times x plus xy prime. So how are we going to simplify that? So we distribute first. Okay, so we have funny face. Okay, so we start with x prime. Okay, so we distribute x prime with x and xy prime such that we have x prime. Okay, x prime plus, okay, x prime with xy prime. So x prime y prime. Okay, next we distribute y with x and xy prime. So we have plus xy plus xyy prime. Okay, what is the x prime equal to? If x is 0, then x prime is 1. So 0 times 1 is still equal to 0. Okay, next is we have x prime. Again is if x is 0, then x prime is 1. 0 times 1 is still equal to 0. So we have 0. Okay, so 0 times y is actually equal to, okay, still equal to 0, but I'm still showing it to you. Okay, so xy, so xyy prime. Okay, so we have xyy prime is equal to 0. Okay, so any number multiplied by 0 is 0. Okay, 0 plus, okay, so 0 plus 0y prime still equal to 0 plus xy plus 0. Okay, so in the end, it just simply equal to xy. Okay, so I'm just showing it to you in detail. Next, we have, okay, for number 4, we have, okay, so we now have the Morgan theorems here. Okay, x prime, y prime, open close parentheses, then prime. Okay, for number 4, we now have a De Morgan's theorem here. Okay, x prime plus y prime, open close parenthesis, and then prime here. Then multiplied by x plus y. So what are we going to do first? So we're going to do first is you have to put the prime inside. So using De Morgan's principle. Okay. So take note, it is already prime. So let's put a prime and then another prime. Okay, so we now have double prime. Okay, and then y prime, double prime. Okay, another prime because it's already prime prior. Okay, y prime, then you add another prime here. But again, in De Morgan's principle, so you have to change the operator from from plus to dot. Okay, so that's how it is. So it becomes x double prime times y double prime, then multiplied by xy. Okay, so prime, okay, it's actually like an inverter or negative. Okay, it's like a negation. Okay, so it's like double negative. So if you have double prime, that means negative negative, and negative negative is positive. So if you have double prime, it just simply cancels the negative, the prime here, such that x double prime is just simply equal to x, and y double prime is just simply equal to y. So in short, so it's just xy times xy, and okay, so x times y is also equal to xy. Okay, so it seems that we have two xy here, xy, xy, and x times x is equal to x, and y times y is equal to y. So the final answer is just simply equal to xy. And last, for number 5, so we also have a case of De Morgan's principle here. So the given is open parenthesis x prime y prime close parenthesis and another prime here. So what are we going to do first? Okay, so we have to put the prime inside. So we have x prime, then another prime, okay, and then for y we have y prime and then another prime, because we're adding the prime. We're adding the prime here, okay, because we want it to put it inside the parentheses. Okay, so what's the operator for this? If there is no indication whether it is plus or dot, so it means it's dot. Okay, it means it's multiply. It's like xy. What does xy means? Xy it means x times y. So it's the same with Boolean theorem. So if there's no operator, whether it's plus or dot, so you assume that it is a dot or multiplication. So it's actually x. So we have here x double prime times y double prime is equal times x plus y. Okay, so we have x double prime. So if you have a case of double prime, so negative negative is positive, so it's actually just equal to x, okay, and y double prime just simply equal to y. Okay, so we have x times y times, okay, I'm sorry, okay, so since this is dot, so we have to change the operator from dot to plus. Okay, so this should be x plus y. Okay, so x plus y times x plus y. It's not x plus y square. Okay, so we have 2x plus y term. Okay, so what will be next? So we distribute. Let's distribute the x first to x and y, then y to x and y. Okay, so we have x, so it becomes xx and xy, and then for y we have xy and yy. Okay, so we now have xx plus xy plus xy plus yy. So xx, so x times x is, okay, x, and of course xy plus xy, so we have 2xy here. So xy plus xy is like x plus x. So xy plus xy is just simply equal to xy, and then y times y is just simply equal to y. Okay, so we have xy plus y. So what are we going to do? So it's either Okay, so let's try to factor out the y. X plus y. Okay, so times x plus 1. Okay. So we have x plus y. So x plus 1 is equal to 1. Okay. If x is 0, 0 plus 1 is still equal to 1. If x is 1, 1 plus 1 is still equal to 1. So therefore, this is equal to x plus y times 1. Okay. Okay, so we have x plus y times 1. Okay, so y times 1 is just simply equal to y. So x plus y. Okay, so the answer is just equal to x plus y. Okay, so there you have it. Okay, so our lecture is only up until here. You might get some info overload. Okay, so that's it for now for Boolean theorems. Okay, so let me see. Oh, so please answer assessment number 2.1 for Boolean theorems and equations. Okay, so that's it. So stay inside, stay safe, and bye.